Life's got problems, let's find solutions. This is Dimensional Analysis Part 2. I'm just going to do some more practice here. If you didn't see the first Dimensional Analysis video, I recommend viewing it. It is available right here. So click on that and see the first one if you need to. But otherwise, we're going to go on to Part 2. I've got a doozy of a problem here for you. Let's check it out. Water is thrown on the Wicked Witch of the West. If she dissolves at the rate of 14.0 milliliters per second, and she has a total volume of 17.54 gallons, how many Martian days will it take before she fully dissolves? Alright, you got plenty here. When you have a conversion type of problem, we should unpack it and see what kind of tools are in our toolbox that we're going to need in order to convert this. So what am I asking here? I want to know how many Martian days it's going to take before she dissolves. My volume that I'm giving and the rate of dissolving is in milliliters. And I'm told how many gallons she is. So I know I'm going to have to convert my volume so that way milliliters and gallons can communicate. I'm going to need to find out how many gallons per second she's going to be dissolving. So one of the first ones that pops out at me is that we do know how many milliliters are equal to 1 liter. There's 1,000 milliliters in 1 liter. Next, we need to know how many gallons are in a liter. So what's the conversion from gallons to liters? For that, you would have to be given it in the problem. Now, if you're in my class, in the back of the book, they often have some conversions between English and metric. And to also be fully honest with you, in AP Chemistry, we're not going to use English too often, but still we want to get you prepared for the real world where sometimes we do have to communicate with these kind of units. So I'm going to tell you that for every 1 gallon, there's 3.785 liters. There's actually more numbers than that. This is a measured value, so it does have 4 sig figs right here. There could be some other numbers, and there are other numbers, but we're just not going to use them. We're just going to take it that far. Okay, we also are going to need to know the conversion to go from seconds all the way to Martian days. So we know that for every 60 seconds, that's equal to 1 minute. We know that exactly. We also know that for every 60 minutes, that's equal to 1 hour. We're going to use 24 hours is equal to 1 Earth day. And now, how many days equal a Martian day? What's the difference there? You know, the amount of time it takes the Earth to rotate on its axis is different than the amount of time it takes Mars to rotate on its axis. A Martian day, by the way, is called a sol. S-O-L. 1 Martian sol is equal to 1.027, and we'll take it to 275 Earth days. You can actually get even more specific than that. So it's kind of convenient. If we ever colonize Mars, which would be pretty sweet, the amount of time it takes for 1 Martian day compared to 1 Earth day, Martian day is just a little bit longer. You could use that extra 0.0275 to just get some extra sleep. That'd be nice. You know, in a complex problem like this, it can be kind of difficult to figure out, like, where do I start this? And something to think about that'll help you is to just decide, how could this problem have been easier? For example, if we knew how many milliliters she was in volume, and we're given this rate of dissolving, could we a lot easier just find out how many seconds it's going to take her to dissolve? Yeah, that doesn't seem like such a monster of a problem. So if I knew what this was in milliliters, then it'd be a lot easier to find out just how many seconds it's going to take her to dissolve. So we could start there. We could say, hey, my first real problem is I need this number of gallons to be number of milliliters. If I knew her volume in milliliters, this would be an easier problem. Also, assuming that I can get this into milliliters, then I could easily convert that to how many seconds it will take her to dissolve. Once I know how many seconds it would take her to dissolve, what if this problem was just telling you, hey, you've got this number of seconds, how many Martian days is that? That might also seem a little bit challenging, but could you take that seconds and go to just hours? Could you take the seconds and go to Earth days? If you were able to get to the point where you had number of Earth days it's going to take her to dissolve, couldn't you then easily convert that to how many Martian days it's going to take using this last conversion? So you just want to kind of take a step back from the problem and think through it as to how could this problem be easier in smaller pieces, and then you might realize your path to the answer. So actually, we're going to start here. We're going to start with this number of gallons, and we're going to convert that over to milliliters. Then, once we get that in milliliters, we're going to use this conversion, how many milliliters per second she dissolves, to find out how many seconds it's going to take her to dissolve. Then we're going to go from seconds to Martian days. Let's give that a shot. That's actually what I want you to do. I've told you how to do it. I've shown you all the tools that you need. Go ahead and pause the video, and I want you to calculate from this many gallons how many Martian days it's going to take her to dissolve. All right, here we go. The Wicked Witch of the West is a 17.54 kind of gal. That actually is the average volume of a human that I was able to look up. So starting there, we want to convert this from gallons to liters. So again, I want gallons to cancel. That was described in the first dimensional analysis video, how to set these up. Gallons is going to cancel, and I want to be left with liters. So now I'm going to take the numbers with me from the conversion factor. The conversion is that 1 gallon equals 3.785 liters that I'm using. So my 1 still goes with gallon, and I've got 3.785 liters. Again, this is how dimensional analysis is so convenient. It can tell you how to set up your problem, whether this number has to go on the top or the bottom. All right, if I stop there, I know how many liters she is. Let's take it all the way to milliliters. Liters is going to cancel on the bottom, and I want to be left with milliliters. So I'm going to say for every 1,000 milliliters, there's exactly 1 liter. That would tell me the witch's volume in milliliters if I do that conversion. Maybe I'll stop the problem here and just calculate that out and see what I get. So 17.54 multiplied by 3.785, and then I multiply that by 1,000. Raw value I'm getting is 66,388.9 milliliters. Alright, so that's her volume in milliliters. Already, we've got an easier problem. Now, I'm leaving this number raw. Everything I'm going to do in this problem is multiplication division, so I'm not going to round until I get to the end. Notice also, using dimensional analysis, we can see that gallons canceled, liters canceled, and so we were only left with milliliters, and so that's what my unit is in this problem. That's how many milliliters she is. Now we can use her rate of dissolving, 14 milliliters for each second, in order to find out how many seconds that's going to take. So I'm going to put my multiplication here. Whether I have to divide or multiply by that number, this is always how I'm going to set it up when I do conversions. I'm going to put that times and then the ratio line, and I've got milliliters for every 1 second. The 1 isn't shown, but still, that's a conversion factor. 14 milliliters equals 1 second it's going to take for that to dissolve. So I want milliliters to cancel, so I'm going to put milliliters here on the bottom since it's in the numerator position for this value. And seconds then is going to go on the top. Then I take the numbers and I put them with it. 14.0 milliliters takes 1 second to dissolve. This is dimensional analysis helping us. It let us know by setting up the units first whether that 14 had to be something we multiplied by or divided by. In this case, we have to divide by it. So that value then is going to be where I start the next leg of this problem. So that's how many seconds it's going to take her to dissolve. Let's convert that over to Earth days. So for every 60 seconds, seconds on bottom because I want seconds to cancel, I've got 1 minute. I want to convert that over to hours. For every 60 minutes, there's going to be 1 hour. Then I can convert that over to number of Earth days. For every 24 hours, there's 1 Earth day. I want to also mention here that it's not that the number is always going to go on the bottom or that the unit you want to cancel is always going to go on the bottom. Most of the time it does, but there's other instances where if we're converting a unit that was on the bottom already, we'd want to put the unit to cancel on the top. So you always have to be thinking about what am I trying to get to cancel, so that way you know what unit goes next. If we stop the problem here, seconds would cancel, minutes is on top and bottom, minutes will cancel, hours is on top and bottom, hours will cancel, and I'll know how many Earth days it's going to take her to dissolve. We can go one more step though, and let's go from Earth days to Martian souls. And so my day is going to go on the bottom, and my Martian soul is going to go on the top. If we check back at our conversion factor, then 1 Martian soul is equal to 1.0275 Earth days. So that's what I want to have here. For every 1 soul, I'm going to have 1.0275 Earth days. So this is then going to cancel out days, and I will know how many souls it's going to take for her to dissolve. So I still have the number in my calculator. I'm going to divide it by 60. So divided by 60. That's how many minutes now it's going to take her to dissolve. I'm going to divide that by 60 again. So that way now I know how many hours it's going to take her to dissolve. Then I'm going to divide that by 24. That's going to show me now how many days, Earth days, and you can see it's not that much. Well, we wouldn't expect it to be a whole lot. She dissolved pretty quickly in that movie. And then we now divide it by the number of days that are in 1 Martian soul. So divided by 1.0275. Here's our value. 0.053416. Some more stuff there. And that's how many souls it's going to take. We go back into the problem to see what do we do about significant figures, and let's look at everything that we used. This was a measured value. So we've got 4 sig figs there. This here was also a measured value. We actually know that there's more numbers from gallons to liters, but we only used 4. So we got 4 sig figs. 4 sig figs. This here is completely infinite. 1,000 milliliters is exactly 1 liter. We've got a measured value here. The rate at which she's dissolving, 14.0 milliliters. We could have tried to measure that which dissolving a lot more carefully, a lot more precise, but we only got to the tenths place in milliliters. So this has 3 sig figs. Since all this is multiplication and division, then already we're limited now in our answer to least number of sig figs, and so far it's 3 sig figs. That's our least. We look at these other numbers here that we used, and this is infinite. These are all infinite. We're treating the 24 hours as being exactly equal to 1 day. We're treating it that way. So this would be infinite too. This here is a measured value, but it's got 1.0275 has got a total of 5 sig figs in it. So as far as least number of significant figures, we would say it's this 14.0. So that means 3 sig figs for our answer. So 0.0, those are just placeholders. Those aren't significant figures. The 5, the 3, and the 4 are. We want to write at least the 5 and the 3. Then for the 4, we look and see that, yep, that 1 is not 5 or greater. So we're just going to cut that off. We're going to say it's 0.0534 Martian souls. If you need some help with significant figures, we do have some videos on significant figures. The video series of significant figures started here in this box. So click on that, and you can watch some sig fig videos and learn how to do that too. I hope you did get some help from this video. I hope that you start using dimensional analysis more and more often. It'll really help you in complex situations. And go ahead and click the like button if you so desire, and we'll catch you next time.